Hi, this is Josh Mandel back with another episode of a guided walk through FHIR. And last time we left off, we had just taken our first look at the FHIR clinical safety checklist, and we'd gone through a couple of the top items on that checklist. And I want to pick up today with some more FHIR safety checklist topics. So the FHIR safety checklist is available inside of the FHIR specification. If you go to Documentation and Clinical Safety, this is the implementer's safety checklist and the conformance-related safety checks that we had talked through last time around. So we've said a little bit about modifier elements and modifier extensions. And today I want to focus on item number 4 on this checklist, which is must support. My system supports elements labeled as must support in the profiles that apply to my system. So there's a lot for us to unpack in this short sentence here. But let's first start off by following this link and trying to understand what must support is all about. So the FHIR specification has this conformance rules page that is the source of truth on must support. And what it says is labeling an element must support means that implementations that produce or consume resources shall provide support for the element in some meaningful way. So let's just make sure we know what we're talking about when we say labeling an element. And I always like to have some examples in mind when I'm thinking about the FHIR specification. And a great example for thinking about elements is the patient resource, one of the more stable and widely used resources in FHIR. And just as a quick refresher, each item that you see in this tree is an element in FHIR. The patient resource definitions include element definitions for identifier and active and name and telecom and so on down the list. So let's see, for example, if we want to understand what this deceased element is all about. Well, I can click on this and get the full element definition details for this. So it's got an element ID that looks like patient.deceasedX, and it can be either a Boolean or a date time. That's what the X is all about. It's a choice data type. And then I've got a couple of these properties here, like is modifier. And this is telling me what that question mark exclamation point is all about from last time. So as a quick review, we see that patient.deceased is modifier. We know it because it's got this question mark exclamation point here. And what that's telling us is this element is labeled as a modifier because once a patient is marked as deceased, the actions that are appropriate to perform on the patient may be significantly different. That is a subtle statement, but I think folks will agree upon consideration that that is probably a fair statement. And so that's why it's a modifier element, because it really changes what it means to be working with a patient if you know that they are deceased. So that's is modifier, but we don't see any kind of flags in this particular list telling us that any of these elements are must support. So these are elements that have different flags. Must support is not one of them. Well, why not? Let's read on. What the FHIR spec says is must support means we need to support the element in some meaningful way because the FHIR specification is intended to be independent of any particular implementation context. No elements are flagged as must support equals true in the base specification. So again, what is this all about? Well, FHIR is designed for use in many contexts. Internationally, lots of use cases. Everything from giving individuals access to their own clinical records, to providing clinical care, to supporting research, to training machine learning models, to bringing government data together in a registry, to taking Internet of Medical Things data and bringing them from a device onto a server somewhere. Lots of different use cases. And this is part of why most elements in the FHIR specification are optional, because in some use cases you need to know them, and in others you don't. So for a patient, for example, almost every one of these elements has a minimum cardinality of 0, because they might be relevant in some contexts and not in others. Actually, everything at the top level in patient is optional. So FHIR is designed for use in lots of implementation contexts, and what we've said is must support will never be marked true in the base specification. So we can look through patient, and indeed we can look through every one of these resources. There's over 150 resources in this release of the FHIR specification. We won't find a single element where must support equals true. Instead, this flag must support is intended for use in profiles that have a defined implementation context. So the specification itself never labels any elements as must support. But when a profile does this, it shall also make clear what kind of support is required. So this is a pretty generic kind of mechanism that we're talking about here. We've got profiles that can flag an element in that profile as must support. And if they do flag any elements like that, they have to describe what it means to support the resource. And so we say here, this could involve expectations around what a system must store, display, allow capture of, include in decision logic, pass on to other data consumers, etc. So this is really pretty generic in the core spec, and it looks like we're going to have to think about some profiles to make sense of how this plays out in the real world. From a safety perspective, though, what it means is that if we're using a profile, we really need to understand what that particular profile says about must support and which elements are labeled as must support. And it's going to be up to those profiles to spell out all of the details. The final note here says, if an element has the property is modifier, it's not necessarily a key element, and it's not automatically must support, but they're more likely to be true. So that's okay. It's kind of a note that says the same kinds of elements that are likely to be is modifier might also be likely candidates for must support in a given profile. So, all right, I think that's about all we can understand from the level of abstraction that we get in the core FHIR spec definition. So we've been looking at hl7.org/FHIR here in the core spec. Let's transition then to understand how must support is used in some real-world profiles. And I'll pick up my favorite example, FHIR US Core. In part, it's my favorite because it's one of the targets of regulations in the US. This is one of the profiles that every EHR system and every payer system needs to build out in order to give individuals access to their own clinical records. And the US Core FHIR specification, let's just go to the home page for a second, includes a set of data profiles and includes various information on the use cases for which US Core is intended. And I'm not going to go into the overview details of US Core. I really just want to focus in on this question about must support. So let me click on conformance requirements here. Turns out not quite the page I want. Let me go back to guidance. And from here, oh, I started off with this page open. How did I get there? General guidance. Okay, so guidance, general guidance. That's where this implementation guide describes must support. What does it say? Let's see. There's quite a few notes here, but let's tackle them because each of these is here for a reason, I promise, and we can think about them together. So what the IG says, this is sometimes called a profile or a FHIR implementation guide. What it says is for querying and reading US Core profiles, must support on any profile data element shall be interpreted as follows. And then there's some notes about the future of US Core page that's going to go into more detail. So let's see. One of the things that we say is US Core responders. So this means like the EHR system or a payer system that is hosting the FHIR data and responding to queries from a client. US Core responders shall be capable of populating all data elements as part of the query results. So this is an interesting point. Let's look at an example here, what it means to say that they shall be capable of populating all data elements. Let's pull up a specific profile in US Core. And again, let's look at patient. We've got that one in mind because we've been looking at patient in the core FHIR specification. Now let's look at in the US Core profiles. What we say in US Core is that each patient must have these three data elements. So an identifier, a name, and gender. We can check out what that star means. And that means every time a resource is created, if it's compliant with this US Core profile, all three of these elements will be present. So that has to do with the cardinality of the elements. So for example, patient.name is going to have formally defined cardinality of one or more. So that means the name will always be present. So far, so good. Now let's look at each patient must support a birth date and an address. So let's focus in on birth date here. we look at the cardinality requirements for patient birth date, we'll see that it's just 0 to 1. So you could have a birthday or you could not. Any given patient instance might correspond to the FHIR US core profile, even if it's missing a birth date. But this little red box here, this S, tells us it's a must support element. And that's consistent with what we see here in the bullet list up top. Each patient must support a birth date. It doesn't have to be there, but it must be supported. What this is driving at is if you're building a clinical data system that is supporting this profile, that is capable of providing US core patients, your system needs to be able to populate birth date. You might not know the birth date of any given patient, but your system can't be entirely ignorant of birth dates. So for example, your internal database that you're using to generate these patients needs to have a field for birth date. And when that field is not empty, you need to be able to populate the birth date element inside of a FHIR resource. So in US core, for producers of data, must support means that the producers need to be able to track these things. And if they know them, they need to include them in the FHIR resources that the system produces. That's the basic intuition about must support for data producers. So that takes us through this first bullet here. US core responders shall be capable of populating all data elements. Not always present, but capable. Let's keep going. US core requesters shall be capable of processing resource instances containing the data elements without generating an error or causing the application to fail. In other words, requesters should be capable of displaying the data elements for human use or storing it for other purposes. So this is a pretty weak requirement, but what it says is if you're receiving data in US core, you should be prepared to receive data with those must support fields present and do something with them. At the very least, be able to include them in your display. So if you're hard coding your display logic for a US core patient into a certain visual template, well, your visual template had better have slots for each of those fields that we looked at. It's got to have a slot for all these required data elements as well as these must support data elements. And it's probably a good thing to support the rest of the FHIR spec too, but we don't call that out so explicitly. So we also say in situations where information on a particular data element isn't present and the reason for the absence is unknown, responders shall not include the data elements in the resource instance returned as part of the query results. So that feels sort of trivial. It's saying if you don't have the data, and you don't know why you don't have the data, then you just don't include it. Fair enough. So even though it's must support, it's not always present. When querying US core responders, requesters shall interpret missing data within resource instances as not present in the responder's system. So again, this is starting to build up the same story on the same intuition that we've already established. If the data is must support and is missing from what you get from the server, you can infer that the reason it's missing is that the server didn't know that information about this patient. So it's saying it's not just missing for an arbitrary reason, it's missing for that reason. What else? In situations where information is missing and the responder knows the precise reason for the absence, then the responder shall send the reason for the missing information values, such as a null flavor from the value set where they exist or using the data absent reason extension. So we might go into more detail on these kinds of things in another talk, but this is really getting at if there's a specific reason why information is not available and you know it, there are ways to convey that to a client. And as a thought exercise, at least, it's worth trying to imagine as a client what you might do with this information when that might be relevant for you. And finally, US core requesters shall be able to process resource instances containing data elements asserting missing information. And so this is just sort of the requester side of this point. If the data aren't there, but a reason why the data aren't there is there, then you have to be able to at least process that, not error out when you see that reason. So those are the basics of the FHIR US core profile must support requirements. And we already looked at the patient resource to see some of the data elements that have been marked as must support. Let's look up one more example of US core allergies to see what's a must support here. So for allergies, required elements are the status of the allergy, a code telling you what the allergen is, and a link to the patient. And then must support elements are the verification status and the reaction manifestation. So let's look at the tree here and see what this means. So the verification status is labeled as must support. And this is telling us really, if this is an allergen that's been, or an allergic reaction that's been confirmed or not. So you might not always have this, but if you do have it, you've got to share it. And similarly, clinical status. Is this an allergy that should be considered active or inactive or resolved? You might not always be tracking this, but your system needs to be able to track this. And if you know it, you've got to share it. So that's the basics on must support. We've looked at US Core. Let's look at one other example of an implementation guide that mentions must support. And this is a work in progress. This is the Smart Health Cards Vaccination and Testing IG. And this is an implementation guide that's really about giving consumers access to their own immunization and testing results, a copy of their data that they can store and share in a verifiable way with other parties. And I don't want to get too much into the use cases for this IG, but I wanted to just pull up must support because it's used in quite a different way here. And as we saw, the base specification really leaves it up to the IGs to describe how must support will be used in practice. So in this implementation guide, here's what we say about must support. First of all, there's a reminder, must support does not mean an element is required. This, of course, is redundant with the core spec, but it can be helpful to give implementers a quick reminder about what we're talking about here. Required elements are those with a minimum cardinality of 1 or greater. Very good. What else do we say? Must support indicates that implementers shall provide support for the data in some meaningful way. We even got a link back to the conformance page of the FHIR spec here. So we're really trying to make sure people know what we're talking about here. Why are we listing must support? What's this all about? Okay, now we get into the meat of it, which is in this implementation guide, support in some meaningful way is defined as follows. So for issuers, and again, this is one of the roles that we describe in this implementation guide, issuers are sort of the generators of data that create FHIR bundles. So issuers shall populate any elements marked as must support if and only if the necessary data are available in their system. This is pretty consistent with what we see in US Core. If you've got it, you need to be able to populate it. We don't quite go as far as saying that you need to support populating these data in your systems. We just say if and only if the necessary data are available in their systems. So that's an interesting question there. But it's clear that you shouldn't include something like data absent reason here. We also say issuers shouldn't populate any elements that are not marked must support unless they believe that it contains valuable information for verifiers. And this is really a use case specific point here. The point of these smart health cards is that they should be as small as possible. The data in them should be minimized. And so what we're saying here is must support is actually being used not just as an indicator of what to include, but also a hint about what not to include. So you should omit elements that are not marked as must support unless there's a really good reason to include them. And then for verifiers, so these are the organizations kind of receiving data and making sense of the clinical data inside of these bundles that come from an issuer. What we say is verifiers shall read and meaningfully process elements marked both as must support and is modifier. And then there's a note about is modifier elements. Of course, it's never safe to ignore those. And then for other elements marked with must support, verifiers may process them at their own discretion. So this is really very little obligation at all for verifiers with respect to must support, because it's really up to their own discretion. Only the ones that are labeled as modifier are the ones that a verifier needs to support, and that already is by definition in the core spec. So this is an example of a different take, a different implementation guide for use in a different context from US Core. And you can see that the requirements on must support, what it means to support in some meaningful way, have changed with the context. So this can be kind of a challenging notion in FHIR, and it pushes a high degree of abstraction on developers working with the FHIR spec. But this concept of must support is an important one. It'll keep coming back as you work with different FHIR implementation guides, and it's important to pay attention to this element because supporting all of the data that are marked in a given profile is going to be critical for successfully implementing that profile. And that's why it's included on the clinical FHIR safety checklist or fire clinical safety checklist as item number 4. So with that, I think we can wrap up this session of a guided walk through FHIR, and we'll be back again, maybe with some additional review of clinical safety checklist items, or feel free to share comments and shout out to me if there's other topics that you'd like to see us discuss. Take care.